Okay, this question gives us the function f of x is log base 3 of x. We want to evaluate a whole bunch of values, construct a graph, then find the domain and range. So we are looking at f of x is log base 3 of x. And we want to go ahead and find 1, 3, 9, 27, 1/3, 1/9, 0. So let's look at that. If I'm going to do it, I want to think of it as y equals log base 3 of x. I like the log on the left. Log base 3 of x equals y. And then I circle the base. 3 to the y equals x. That's how I like to think of it. Now, what are some of the values that they wanted me to use? So I have x and I have f of x. I believe 3 was the first one. So I want to find y, right? F of x is the same thing as y. So if x equals 3, 3 to the y equals 3. Well, that's 3 to the first, yes? Boom. If x is 9, I have 3 to the y equals 9. But 9 is what? 9 is 3 to the second, so y equals 2. If I have x equals 27, I have 3 to the y equals 27. 27 is 3 times 3 times 3. That's 3 to the third. So y equals 3. You get the idea? Now, what are some of the other numbers that they wanted? 1, okay, that's a good one. 1, if I get x equals 1, 3 to the y equals 1. 1 is 3 to what power? 3 to the 0 power is 1. So y equals 0. Then I have 1/3 here. So if x equals 1/3, right, 3 to the y equals x. 3 to the y equals x. So 3 to the y equals 1/3, but 1/3 is 3 to the negative 1. 3 to the y equals 3 to the negative 1, so y equals negative 1. And similarly, if x equals 1/9, right, 3 to the y equals x. So 3 to the y equals 1/9. So 3 to the y equals 1 over 3 squared. 1 over 3 squared is 3 to the negative 2. 3 to the y equals 3 to the negative 2, so y equals negative 2 when x is 1/9. Y is negative 2. So we filled out that chart following the directions of the problem. So let's go ahead and go to Desmos and see if we can draw a graph with those points. So we have 3,1 and 9,2 and 27,3 and 1,0. There's 4 of them. And you can see the 27,3 is way out there. And then the fraction ones I'll do in a separate row here. 1/3, negative 1. And 1/9, negative 2. I'll make those points black as well. So there we go. If we're going to draw a graph, it's going to asymptote this way and then grow very slowly that way. Right? We see the idea. So I can actually go ahead and connect them. Graphing f of x equals log base 3 shift underline. Whoops. Shift underline log base 3 of x. And there's our graph. We want to know what the domain and range is. The domain is a set of all of the x values. The range is the set of all of the y values. right? That's what we're looking for. We have our graph. We want the domain and range. So looking at it, what do we see? Domain, we're not allowed to use 0. We get very close to 0, but never actually get there. We can't use any negative numbers. Notice there's no negative x values on our graph, negative y values for sure. But domain is x values. The lowest x value you see is something a little bigger than 0. So it gets close to 0 without ever actually getting there. So the domain of this thing are x values bigger than 0. So the domain we have is x greater than 0. So that, of course, is round bracket or round parentheses 0 to plus infinity. Now, what about the range? What are the y values you see? Well, they certainly get as low as you want them to go. Do you believe that the y values get as high as you want them to go? And that's a little harder to believe just because it's growing so slowly. I mean, will the y value ever get to 10? It will, but it's going to take a long time. Let's see if I can adjust the window to a point where it actually even just gets to 10. Get to 10 yet at 100? No, I don't think so. What, 1,000? Get to 10 yet at 1,000? Still not at 10? How about 10,000? Did it finally get to 10? Nope. 100,000? So you see how long it takes to grow. And eventually it'll get there, although we may go beyond the realm of the calculator. So there's a few zeros. And yeah, eventually it gets to 10. It got to 10 around here, around 60,000. But wow. So it is growing. It'll hit all the y values, but it takes an awfully long time to get there. But our range is all real numbers. So the range is minus infinity to plus infinity. Now we followed the directions of the problem, but if I were asked to graph y equals log base 3 of x, I think it's much simpler to think of it as an exponential rather than thinking of it as a log. Log base 3 of x equals y. We do our usual thing, circle the base, box the exponent, 3 to the y equals x. And then pick values for y and see what the corresponding values are for x. Get the idea? Pick values for y, like if y is 0, what is x? 3 to the 0 is 1. If y is 1, x is 3 to the 1 is 3. If y is 2, x is 3 to the second is 9. If y is negative 1, x is 3 to the negative 1, which is 1/3. Y is negative 2, x is 3 to the negative 2, which is 1/9. If I have to graph a log question quickly, that's the process that I use to find the points that work.